what would inverse variation look like in an equation? The most basic form would be y equals 1 over x. So we're dividing by x. This is really different from linear, and we'll see that once we graph this. But another equation would maybe be y equals 3 over x, or y equals 2 over x squared, or perhaps y equals 17 divided by the square root of x. In all of these cases, we're dividing by x. So as x gets bigger and bigger, let's look at this first example. As x increases, the y value gets progressively smaller. So if x was 2, this would be 1/2. If x was 3, this would be 1/3. You might hear my son in the background. 1/4, 1/5, 1/10, and so on. So these numbers, 1/3, 1/2, 1/4, are getting progressively smaller as x increases. So let's go ahead and make a table for y equals 2 divided by x. When x is -4, this would be 2 divided by -4, which is -2. When x is -2, y is -1. When x is -1, y is, oh, I messed up on my first table. Let me try that again. When x is -4, y is -1/2. There we go. When x is -2, y is -1. When x is -1, y is -2. When x is 0, we have a problem because we'd be dividing by 0. And so actually, let's go to the next slide. So I filled in the table that we had on the previous page and just expanded out. And what I've done is I've picked some fractions where x is getting really close to 0 on the negative side and really close to 0 on the positive side. So when x equals -1/2, y equals 2 divided by -1/2. Dividing fractions is the same as multiplying by the reciprocal. So what we end up with is y equals 2 times -2. So the reciprocal of -1/2 is 2. So y equals -4. Similarly, when x is -1/3, y equals -6. When x equals -1/10, y equals -20. And so I can see that as x is approaching 0 from that negative side, y is shooting down toward, and those y values are getting progressively smaller. This is the opposite what's happening on the positive side. When x is +1/10, y is +20, 6, and 4. So what we have, plotting these points, I'm going to pause the video and make the graph. Here's our graph. It actually ends up looking like it's two different lines, but this is the graph for just y equals 2 divided by x. The disconnect is centered around that divide by 0 that we would have run into. So for the trend of this graph, you can see that as x increases, the y value is getting progressively closer to 0. Not only that, but the y value, those steps are getting smaller and smaller. Like there's a bigger jump going from -1/2 down to, from x equals +1/2 to x equals 1, there is a decrease of 2 in a step of 1/2. But then going one full step, one might expect the decrease to be even bigger, but instead the decrease is just down 1. And on the next step, it's down 1/2, and so on, progressively smaller. So if you see this pattern, this kind of inverse pattern, that's your best clue that this is inverse variation. So how can you tell if something is an inverse relationship? It's easiest to tell from an equation with the variable on the denominator, or a graph. In a table, a change in the independent variable results in an increasingly small change in the dependent variable.